So now let's have a look at this image. We are denoting the width of the pillar here to there as A, and denoting the width of the O as C. When I come here, I do the same. So here becomes A, here becomes B. That is the length of the pillar. Okay, you know, to calculate, it is going to be length times breadth, right? So I have this as B, this side as A, which is B here, and this as A. Now, but then we have said earlier that assuming I have this red line drawn, this side is the A, but then this pillar to the side is going to take half of the load, which is the C. We have stated earlier that it is going to take half of that. So it is going to take half of the C, half C, and then half C here. Then when I come to this side, this is going to be B. Then this man will take half of the C and half of the C. So if I have half plus half, it's going to be what? 1, right? And that is why we have A plus C. And when I get here to, this pillar has taken half of C and half of C. So half plus half is 1. And so we have, so it was going to be B plus half of C plus half of C. This together will give me B plus C. And that is what is written here. And it's the same here. So A plus C and B plus C. Please take note of this. If you have any questions, ask. We are going to use it for calculations.
Doc, please go over it again.
So what we are saying is that we are taking this being our pillar. This is the pillar. Where the big A is the pillar. Then we are denoting the dimensions of the pillar as A and B. Okay, we are denoting the dimensions as A and B. And we have stated earlier that the tributary area principle is saying that if I have a pillar, the pillar does not bear the entire load that is above it, but it bears up to half of the space to its left, half to its right, the front and the back. So the shaded region is the amount of load the pillar is going to carry plus the load directly above the pillar. Good. So hello. Go ahead.
So is it half the size of the pillar itself that is going to like carry, or like which half is that?
Let me see if I can demonstrate that sheet here. So let's assume these are square pillars. Okay, these two things are square pillars. We are assuming they are square pillars. And so what's this? So let's assume this being square pillars. And these square pillars are to carry a load on top of it like this. Okay. If this pillar were to carry the load, you should not think that this pillar here on my left like this, is not going to carry the whole load all to this pillar. Then what will be the use of this other pillar on the side? So the tributary area principle is saying that if I have any given pillar like this set up, this pillar here, this pillar here is going to carry the pressure that is coming. It will divide it equally among themselves. So this man on my left will carry the pressure equally. And so if the space here is 2, the area here is 2, they are going to share. This man will share the pressure up to the middle. And then the remaining half is given to this other man here. That is what the tributary area principle is saying. So if you have a pillar and there are 2 pillars, 3 pillars, 4 pillars, each pillar carries the burden up to the middle of the space between the 2 pillars. That is what this principle is saying. And so if I have this pillar here, with this pillar denoted A in the middle, that I have highlighted with the red, the whole of the shaded region is the area whose stress it is going to carry. Is it clear?
Yes.
Good. So this shaded region, so plus even the, so it's more or less like this. So the whole of the shaded region is the amount of pressure this pillar, if I erect a pillar at the center, that is the amount of load it is going to carry right from the point the pillar is to the top. So whatever load is up there in that dimension, that is what it is going to carry. And since that is the case, then let's assume this is the pillar, and we denoted the dimensions of the pillar as what? And it's a rectangle. So since here is A, since here is A, this side will also be A. This is B, this side will also be B. So if from here to here, what is the distance between them? So assuming I have this to that, but then we have denoted that the distance from here to here is what? C. So this man is going to take half of the load here, and this will be half of C, half of C, and this is also going to take half of this load here, and that will be what? Half of C. Then I come here, this distance is known. So I know this distance to be C. So this man is going to take half of that C. And when it comes to this dimension 2, it takes half of it, half of that. So then I just want to prove this B plus C and the A plus C. So now I have C over 2 plus A plus C over 2. If you put all together, you are going to get half of C plus another half of C. What will it be?
1 C.
That will be 1. So that will be 1C. But in algebraic expressions in our maths, we don't say 1C, so it is C.
C.
Good. So that is why you have C here. So this A here is representing the length of the pillar, and the C here is representing the length of load it is taking as extra, sharing with the other pillar next to it in that direction. Then when I come to where the B is the width of the pillar. And the C here is half plus half of the other dimensions between it and the next pillar. And so half plus half again is giving us 1. And that is why we have B plus C. Are we good to go?
Yes, Doc.
Good. So in the same way, if I have a rectangle, I am going to have the same issues here. Tributary area. Whatever pillar is to my left, we share the burden equally. This one is NC. No contribution, no chop. So that is why we're talking about the pillar robbing. If, assuming we take away this pillar, what do you think will happen? This distance here, assuming there's a pillar here, and there's another pillar here, and these 3 pillars. So to this side, this man here is going to share the space here with this man. And then out of greed, we rob this pillar off. What will happen? This man here has now got a burden of sharing this weight here. So whatever weight it was bearing here, this man will give half of its burden to it, to the left, and this man, and then it will give the other half to this nigger here. So that is what the tributary area is saying, that the pillars share the burden. So if it were to be rectangle too, it will be the same. This is the width of the pillar, and this is the width of the ore, which is this place, width of the ore. That is the gallery, the space between the 2 pillars is what we are terming the width of the ore, because since the space is not there, means we have mined it, and that was all we mined. So in our case, we are saying width of ore, but some places you can call it the gallery, that is the space. Then this is the length of the pillar.